Greetings everyone, and welcome to the physics presentation. In today's presentation, we are going to discuss about how to produce electricity from living trees. This is part of the educational project of the Lebanese students on the indigenous Koso or Hagenia abyssinica tree. The components of today's presentation include defining terms like electricity and smart electrification, explaining the different methods and techniques to generate electricity, and discussing the methods of harnessing electricity from living plants. Finally, we will be doing a course integration and curriculum plus on how to generate electricity from Koso tree. Electricity is simply defined as the flow of electrical power or charge. It is a secondary energy source which we get from the conversion of other sources of energy like coal, natural gas, oil, nuclear power, and other natural sources, which we call primary sources. The means of using electrical energy to replace other forms of energy such as fossil fuel is called smart electrification. It also means using the advantage of electricity offers to make overall better use of energy. Electricity is an essential part of modern life and important for every country's economy. People use electricity for lighting, heating, cooling, and refrigeration, and for operating appliances, computers, electronics, machinery, and public transportation systems. Despite surviving thousands of years without electricity before, we have come to depend on it to complete our everyday tasks and have built our lives around it. But this doesn't mean that there aren't people who live and survive without access to any electricity at all. According to recent researches, 940 million people do not have access to electricity globally. That is 30% of the total population of the world. And according to the World Bank report in 2018, in Ethiopia, more than 60 million people live without access to electricity. Electricity is produced in power plants capable of drawing electrical energy from primary energy sources. These primary energy sources are maybe renewable, like wind and solar power, or non-renewable, like coal, natural gas, etc. Electricity has been generated on an industrial scale since 1881. In 1882, a full-scale central power station with a system of conductors to distribute electricity to end users in high-profile business districts was established in New York City. Let's see some of the different sources from which electricity can be generated. Coal power generation. According to the World Coal Association, coal-fired power plants currently account for 41% of global electricity, with almost half of that coming from China alone. Coal-fired power plants use steam coal as source to generate electricity and consequently emit a significant amount of harmful gases into the atmosphere. Nuclear power generation. Using a nuclear fission reaction and uranium as fuel, nuclear power plants generate high amounts of electricity. As nuclear power plants emit low greenhouse gas, the energy is considered environmentally friendly. When compared to renewable sources of energy such as solar and wind, the power generation from nuclear power plants is also considered more reliable. Though the investment required to set up nuclear power plants are huge, the costs involved in operating them are low. Nuclear energy sources also have higher densities than fossil fuels and release massive amounts of energy. Due to this, nuclear power plants require low quantity of fuel but produce enormous amounts of power, making them particularly efficient once up and running. Hydroelectric power plants. Hydroelectricity is produced by harnessing the gravitational force of flowing water. Compared to fossil fuel-powered energy plants, hydroelectric power plants emit fewer greenhouse gases. However, the construction of hydroelectric power plants and dams requires huge investment. According to the International Hydropower Association 2017 Hydropower Status Report, an estimated amount of 31.5 gigawatt of hydropower capacity was put into operation in 2016, bringing the world's cumulative installed capacity to 1,246 gigawatt. China alone accounted for almost one-third of the global hydropower capacity and added around 11.74 gigawatt of new capacity that year. Hydroelectricity is a renewable source and has minimal environmental impact. Geothermal power plants. The three main types of geothermal plants include dry steam power stations, flash steam power station, and binary cycle power stations, all of which use steam turbines to produce electricity. As of May 2015, 24 countries were home to a combined geothermal power capacity of 12.8 gigawatt, according to the report of Geothermal Energy Association. Geothermal power plants are considered environmentally friendly and emit lower levels of harmful gases compared to coal-fired power plants. Wind power plants. In recent years, there has been a rapid growth in the number of wind farms across the world, underpinned by technological advancements. As wind is a naturally occurring source of energy, there are no limitations to harness its power. Operational costs involved in maintaining wind power plants are low after the erection of wind turbines, and they are generally considered cost-effective. Wind farms can also be built on agricultural lands without causing any interruption to cultivation activities. However, maintenance of wind turbines may vary, as some need frequent check, and wind power projects typically require huge capital expenditure. Solar power plants. Solar energy plants convert energy from the sun into thermal or electrical energy using one of the cleanest and most abundant renewable energy sources. They generally do not require high maintenance and last for about 20 to 25 years. The International Energy Agency projected in 2014 that by 2050, solar photovoltaic would contribute about 60% to the worldwide electricity consumption, and solar would be the world's largest source of electricity. However, initial costs involved in setting up solar power plants are high, and the installation of solar power systems requires a lot of space. Wave power generation. Wave energy is produced when electricity generators are placed on the surface of the ocean. The energy provided is most often used in desalination plants, power plants, and water pumps. Energy output is determined by wave height, wave speed, wavelengths, and water density. To date, there are only a handful of experimental wave generator plants in operation around the world. Machinery able to exploit wave power is generally known as a wave energy converter. The consumption of electrical power is growing rapidly all over the world due to the increase of human population and technological advancements. Electricity is the most versatile and easily controlled form of energy. At the point of use, it's practically loss-free and essentially non-polluting. Electricity is weightless, easier to transport and distribute, and it represents the most efficient way of consuming energy. Green energy. Sustainable energy sources, which are pollution-free and environmentally friendly, are one of the key challenges of world's future society. Recent researches have confirmed that living plants are literally green power sources, which may become one of future's electricity supplies that perfectly integrates in natural environments and is accessible all over the world. Scientists now are using different techniques to generate electricity from living plants. Energy from trees. Trees can absorb several thousands of watts of sunlight during the sunnier hours of the day, but they use this energy essentially to stay alive. By shoving electrons, it's possible to recover a very low electric current, generating an energy 1 million times less powerful than the tree wants. According to researchers, this faint amount of electricity is actually created by an imbalance in the pH between the soil and the living tree. Trees seem capable of providing constant voltage between 20 and a few hundred millivolts. A team of scientists at the University of Washington built a device, a boost converter, that takes a low incoming voltage and stores it to produce a greater output of 1.1 volts. As electronic components continue to shrink and require less power, it's possible that tree electricity could one day have a wide range of uses. Energy from tree leaves. Certain leaves have structure which makes them convert mechanical force applied at their surface into electrical energy because of the specific composition that most plant leaves naturally provide. In detail, the leaf is able to gather electric charges on the surface due to the process called contact electrification. These charges are then immediately transmitted into the inner plant tissue. The plant tissue acts similar to a cable and transports the generated electricity to other parts of the plant. Hence, by simply connecting a plug to the plant stem, the electricity generated can be harvested and used to power electronic devices. Scientists in Italy show that the voltage generated by a single leaf may reach to more than 150 volts, enough to simultaneously power 100 LED light bulbs each time the leaf is touched. Researchers also showed that a hybrid tree made of natural and artificial leaves can act as an innovative green electrical generator, converting wind into electricity. When wind blows into the plant and moves the leaves, the hybrid tree produces electricity. The electricity generated increases the more leaves are touched. Consequently, it can be easily upscaled by exploiting the whole surface of the foliage of a tree or even a forest. Plantee Technology. Plantee is a technology that generates electricity using living plants. This technology was developed at Wageningen University and was patented in 2007. A plant produces organic material through photosynthesis. Part of this organic material is used by the plant for its own growth, but not everything is used by the plant. The remaining part is excreted via the roots to the soil. In the soil, around the root of the plant, bacteria break down the organic material. In the degradation process, electrons are released as a waste product. The Plantee technology ensures that we can use these electrons as electricity. Electricity from the Plantee technology has been in use for powering outdoor lighting and other small to medium scale applications such as Wi-Fi or charging mobiles, or incorporated into a green roof to generate electricity for buildings. Due to high oxygen level, the technology generates large amount of electricity from wet areas such as a peatland, mangroves, rice paddies, and deltas. Let's see how the concepts that we have discussed so far could be integrated to the koso tree. Hagenia abyssinica or koso is a species of flowering plant native to the high elevation Afro-montane regions of Central and Eastern Africa. It's a tree up to 20 meters in height with short trunk, thick branches, and thick peeling bark. It's often dominant in the woodland zone just above the mountain bamboo at elevation of 2,000 to 3,000 meters. Although koso is very well known for its medicinal uses, it has also various other purposes such as construction, furniture, fuel wood, and soil fertility management. On their project proposal on the koso tree, the Kelebawiyan students have come up with a hypothesis that since the roots of a koso tree can handle wet environment, electricity can be generated from its trunk and also with the help of the Plantee technology. This makes pretty good sense, since the technology works in waterlogged environment, which means the plant roots should be able to handle a wet environment, which koso tree roots do very well. Now it's time to see the practical applications of the electricity generated from the living plants. The few milliwatts of electricity that is generated from the living tree are enough to supply simple electric circuits such as temperature sensors and small transmitters. These trees produce enough electricity to allow the temperature and humidity sensors tapped into them to wirelessly transmit signals 4 times a day or immediately if there is a fire. We can protect trees like koso and other indigenous trees from fire by spreading such sensors in forests. The artificial tree. Scientists at the VTT Technical Research Center of Finland Limited have produced what is called to be the first artificial electricity harvesting tree. It can generate small-scale power from solar energy, vibrations, and temperature differentials. It takes the shape of a leaf at only 0.2 mm thick, which is manufactured by 3D printing and screen printing. You can charge your phone from 200 of these leaves, being capable of 10.4 watts and 3.2 amperes. The long-range sensor device. With the help of the Plantee technology, a prototype device is developed. This device uses the electricity generated by living plants to transmit long-range messages about air humidity, soil moisture, temperature, cell voltage, and electrode potential straight to a satellite. These devices are completely self-sustainable and operate independent from sunlight day and night. Application for this technology can be found in areas that require critical data gathering, such as agricultural land in remote regions, rice fields, or other aquatic environments, without the need for external energy source. Let's finish up today's discussion with a recap on what we have seen so far. In today's presentation, we have defined electricity as the flow of electrical power or charge. We have seen that primary energy sources can be classified as renewable and non-renewable. We have also discussed how to generate electricity from living plants. And finally, we have seen that it's possible to generate electricity from causal tree, from the trunk, and with the help of the Plantee technology. This is all we have for today. I hope you find our presentation useful. And thank you for being with us. Till next time, goodbye everyone.